All right, I'm going to try to walk you through a very simple version of what you're going to experience in the homework. And in the process, I'm going to hopefully reinforce a few of the things that I shared with you in the lecture and in perhaps kind of a ragged fashion. I have to admit I'm a little bit rushed trying to get this material out. So what we've got here is a set of 6 switches, and the switches are S1, S2, S3, S4, S5, S6. We have 3 workstations. I better get some links for those workstations. Let me do that real quick. There's one link there. There's another link here. And you can barely see those, but that's the way it goes. All right, so A, B, and C, you can see their MAC addresses down here. For instance, A's MAC address is 000102030405. B's MAC address is 11111111111, etc., etc. Over here, I've got 4 X's. We're going to use those for the spanning tree protocol that we will run here in just a second. Then I have a couple of got a couple of forwarding tables for the switches, and I'm only going to work with S1 and S2 for this example, and hopefully that will help you out. And you can sort of extrapolate the rest. All right, so what we're going to do first is we have to figure out what ports are going to go into blocking mode. In the spanning tree protocol, we've got a lot of loops here. And you can just see them all. There's a loop S1, S2, S5, S4, S1. That makes a loop. S2, S3, S6, S5, S2. There's another loop there. These have to be shut down. Ethernet doesn't work with a loop in it. So what we're going to do is we're going to say all these guys come up and they start running the spanning tree protocol. And in the spanning tree protocol, they all advertise to their neighbor what their root ID is, and the root ID with the lowest number will become the actual root. So S1 advertises to S2 and S4, and it says, hey, I'm the root. And S2 and S4 go, well, we have a higher number than you, so for us, you are the root. S2 advertises, this all happens simultaneously. S2 advertises to S1, S5, and S3, and initially it says, hey, I'm the root. Well, when it hears from S1, S2 says, I'm not the root, S1 is. But on that first conversation between S2 and S3, S3 will say, hey, S2, you're my root. Well, when S2 says to S1, hey, you're the root, S2 will then re-advertise, I'm not the root, S1 is the root, and S1 is reachable through me. And S3 and S5 will both go, oh, okay, S1 is the root, and I can get there. Now, S5 has 2 paths to the root. It will take the shortest path. Well, these are both equal distance. And so now what do? S5 will take the path that is the shortest, and if there's a tie, it will take the path with the lowest ID that it's connected to. So let's just go real quick here. S1 becomes the root. S2 and S4 are directly connected to S1. S5 has to choose a path to be connected, and he says, I'm going to go through S2. That means that this link down here, hopefully you can see my cursor, this link right here, the P2, P3 link between S4 and S5, is going to be put into blocking mode. Now, it is possible that we would have a computer connected to this link, and I'll just pretend to put one here. Let's say there was a computer that was connected into this link here. So you see, this link still has to be reachable, but it can only be reachable by one of these two. And what's going to happen is S4 and S5 will talk, and S4 will say, hey, I'm closest to the root. I will be the one who manages this link. And so S5 will block his port 3. I'm going to put a red X there. You need to do the same thing in the homework. So now S4 can talk to this link. S5 is no longer talking to it. It does listen. I'm not going to worry about that particular bit right now. And in just a second, I'll put up a little diagram of what the actual tree looks like. Now, we now see also that S3 and S5 can both get to S1 through S2, but S6 has the same issue. He has 2 paths that are 3 hops. He can go from S6, he can go 5, 2, 1, or he can go 3, 2, 1. And what he does is he says, you know, I've got to pick the one through the lowest link. and he says, I am not going to go through S5, I'm going to go through S3, which means this S5, S6 link has to be blocked. And so S5 and S6 negotiate, and S5 says, hey, I'm closest to the root, and S6 says, fine, I'll block my port 2. And now S6 only has port 1 active. S5 has port 1, here's port 1, and port 2 active. Okay, so if I were to draw this tree, what I would, and I'm going to do a Control Z and undo this in just a second, I would say S4 is connected there. See, because what I'm doing is I'm showing that these links are blocked. And now you can see a tree. S1 has S4 and S2 off of it. S2 has S5 and S3 off of it. S3 has S6 off of it. But from an actual transmission standpoint, S4, S5 is blocking, but S5 has put its port 3 in blocking mode. S6 has put its port 3 in blocking mode. Control Z to get those links back. All right, so now we have the spanning tree. S1 is the root, and if you're going to go, if A is going to send a packet or frame to C, the path is S4, S1, S2, S3, S6. See, the path, there's a shorter path here, but it's blocked. Port 3 is off and port 2 is off. Also, if switch 5 is going to send if node B is going to send a packet to node A, it'll send it to S5, and S5 will say, okay, once it knows everything, S5 would send it to S2, S2 to S1, S1 to S4, S4 would deliver it. S5 is blocking on port 3, that's why he can't transmit to switch 4 directly. Now if switch 4 goes down, S5 will be able to figure that out, and S5 will unblock port 3 and start listening and transmitting on that link again, but we're not going to cover that. We're not going to worry about that right now. All right, so now we are ready for what happens when A sends its first packet to C. Now, if all the switches have been operating a long time and they all know every address, then over here in S1, he will know that I'm just going to put 0405-05 here. That's A. And if you look, what is S1's port that it uses to get to A? It's going to use port 2. So S1 will have port 2 there. Oh, not port 23. Now, S1 says, what about node B? I'm just going to use the last 4. And note that node B for S1 uses port 1. He has to go from S1 through port 1 to S2. So his forwarding table looks like that. Similarly, 22-22. Now remember, this is all from S1. S1 is what we're looking at here. That's node C. And I got a copy right there. We'll live with it. That also goes through P1. What about switch 2? Switch 2 says for 04-05, he would actually send out his port 2. And for 11-11, he would send out his port 3. See, S2 uses port 3 to send to switch 5 to deliver to node B. Now again, this is assuming that all the switches have learned all the addresses. All right, so what about 22-22? He would use his port 1. All right. So now, if node A is going to send a frame to node B, the frame, let me actually see if I can make a little frame here. I will insert a 4x1 diagram. We'll make this small, and we'll make this look like a type field. All right, so sorry about this. This is going to be the frame that A is going to send to B. Let's see if I can color this a little more nicely. That's good. All right, so hopefully this shows up. Yeah, good. So A is sending to B. The destination address is 11-11-11-11-11-11. I don't have room. The source address is 00-01-02-03, etc. Let's just say the type is 0806. This is an IP frame. I'm sorry, an ARP frame. And then it's got, here is the data, and I didn't put the CRC on the end. So A is going to send this frame, and he transmits it up his link. Now, he doesn't know the switch is there. He thinks he's just talking to Ethernet. When switch 4 receives it, the first thing switch 4 does is he looks, he says, okay, I've just gotten a frame on my, okay, boy, gotta add something here. Slight oversight. I'm going to make this P8. There's some ports we don't know about, but the port that the computer is connected to is port 8 here. And over here, B is connected on port 11. I'm going to make this bigger now. Thank you very much. And the other, see, every computer is also uses a port on the switch. And here is port 18. Okay. And I'm just for fun, just to try to make this a little cleaner, we'll make another switch. I'll make this one S4, and for S4, now you can see that he sends thing. If he wants to send something to node A, he sends it out port 8, and everything else for him goes up port 1. All right, so let's return back to the example. A transmits a frame to switch 4. The very first thing switch 4 does is switch 4 says, okay, I just got a frame from P8. He looks in the source part of the Ethernet frame, and he says 000102. He goes into his own forwarding table, and I'm going to make this a little smaller font-wise so I can actually type it. 00-01-02-03-. All right, and I'll make this a little bigger again. Make it bigger this way. There we go. Goes into his table and goes, oh, I already have that one. It's on port 8. That's good. Then he says, now I have to deliver this thing. And he looks and he says the destination address is 1111. And then he looks in his own frame up here, his own forwarding table, and he says, oh, I know where to send that. I send that to P1. And he just transmits it up the P1 port where it's received by S1. The very first thing that S1 does is he looks at the source address from the frame he just received. And he sees it 0001, 02, 03, 04, 05. And he goes to his table and he says, I have that. I don't need to store it. He then looks at the destination address, 11111111. He looks in his own table and he goes, oh, I have to send that out port 1. And he sends it out port 1 and it arrives over here at S2. Now S2 does the same thing. They all do this. They all say, I got to look at the source address, and if I don't have that in my table, I need to update my table. Well, he already has, switch 2 already has this MAC address in his table. He doesn't update anything. He looks at the destination address, the first field in the Ethernet frame. It's all ones. He comes into his table and he goes, oh, if I'm going to deliver that, I have to send that out P3. Here's P3. See, the address of the destination is here. The forwarding port is P3. He then sends it down to S5, who has his own table, which I didn't draw here. His table says, hey, to deliver to 11111111, send it out P11. He sends it out P11. It gets delivered to B. And that's how it works when all the tables are full. All right. So now let's look what happens when everything is empty. All right. And this is a completely different situation. The switches have just been turned on. And this is the second part of your, or a secondary part of your, pardon me, homework. So now everything's just been turned on, the tables are empty, and the same situation. Node A, let's see if I can make this a little bigger. Maybe I can, maybe I can't. I don't know, we'll see. And I'm going to make this smaller. Hopefully you can see that on your screen still. And now I can actually put the full MAC address there, and it feels a little bit better to me. 3-04-05, 0x-0800. This is an IP packet. Here is an IP packet. Okay. So now, this is node A. Of course, that wouldn't actually be in the frame. Node B. Wouldn't you know it? That there, okay. Now, this is, I'm hovering over or highlighting, that's the destination, that's the source, That's the type field. This is the actual data, which is the payload for the Ethernet frame. This is going to be sent from A up here on switch 4 to B, but nobody has anything in their forwarding tables. So he delivers it to switch 4, and switch 4 goes, yay, I have my first frame. Switch 4 looks into the source part of the frame, and he goes, okay, I now have a MAC address. And he also knows that it came on port 8. So he goes into his MAC address field, and he says, I now get to put an entry into my table. And so he says A came from port 8, and he's done. He's used the information in the source field to update his table. Now he looks at the destination. He goes, okay, I'm supposed to deliver this to 111111. And he looks in his table and goes, I don't know where that is. So he floods it. He sends it out every single port. He actually sends it out port 2, which, remember, port 2 is blocking on the other side, so it's really not connected here. I didn't like the way that did that. It's really not connected. I'll do that over here too. That'll help us just a little bit. It's really not connected at all. But he floods it out port 2, which doesn't go anywhere. He also floods it up to switch 1. Switch 1 receives it. Same exact process. Notice that he didn't flood it out port 8 because he got it from port 8. Switch 1 receives it, looks in the source field, and says, I don't have that yet. So he says 00-01 ... That came from, he enters it, P2. And now it's time to forward. He takes the destination address, all ones, looks in his table, which is empty, and goes, I don't know where to do that. I'm going to have to flood it. He got it from port 2, so he won't send it out port 2, but he does send it out port 1. Switch 2 receives it, goes through the same process. Says, you know what? I'm going to jank this up pretty good. There we go. I've just received this frame from this address. Now notice switch 2 says it came in his port 2, so he fills in his table. And now switch 2 says, I don't know where to send this. So he actually sends it out port 1 and port 3 because he's flooding it. Now when S3 receives it, he'll update his own table, and therefore he learns that for S3, the direction to node A is out port 2. S3 will flood it to S6. And in this way, S3 and S6 will all learn what their path to node A is. Now when S5 receives it, he will flood it. He'll build his table, and then he'll flood it. He'll send it out P1. He'll also send it out P11, and B will receive it. And so in this way, the frame actually does get delivered, even though they don't know where it's going, because they flood it when they don't know the destination. All right. And then when B sends a frame back to A, notice that switch 5, switch 2, switch 1, and switch 4 will all have A's address in their forwarding table. So when the return frame is sent, they won't have to flood it. They can send it directly out the port that they know will deliver it to node A. And so switch 3 and switch 6 will never hear about the frame if B sends one back to A. All right. Now, if B sent a frame to C, then that would get flooded everywhere. Everybody would learn where B was, and that's it. All right. So what you have to do when you do the homework is you have to figure out where the spanning tree is going to block things. Then I've given you a couple of situations where you assume all the tables are completely full, just like they were at the beginning of this video. And then I've given you a situation where the tables are partially full, and you have to tell me exactly what happens on a node. And so for when you do that, go to that node, figure out it receives this, and then what happens? It receives it. Does it have to flood it because it doesn't know where it is? Don't forget to always have the switch checked to see if it knows about the source address. If it doesn't know about the source address of the frame it just received, it will always update its table. All right, I hope that helps you guys do the homework, and this gives you a little bit of a working knowledge about how these switches build their forwarding tables and learn how to transmit frames dynamically. It's a very simple system, but it works beautifully. And that's it for this video. Good luck this week, guys.